Today is April 16, 2024. I'm filming over New York City in search of UFOs, so I can videotape some of them. I videotaped last night. There was nothing on the, nothing in the skies. I videotaped this morning. There was nothing in the skies. So to my left is going to be New Jersey, and to my right is Brooklyn. So there's nothing at all happening now, but at least the traffic is moving smoothly. So hey, I'm just going to give you a view of New York City. I'm always going to be on the lookout. So if I see any anomalies, I'm going to start videotaping. But for now, that's just a view of Manhattan across the Hudson Bay. And then we have the Verrazano Bridge. So let me show you some traffic if I can. There we go. So I'm going to cut the video short because I'm certain you don't want to just watch the view of the city. Yeah, I just remembered. I had asked a question in one of my videos. I said, if we were to take all the rubbish out of the universe, and what I meant by the rubbish was all the galaxies, planets, forces, particles, fundamental particles, dark holes, black holes, dark matter, dark energy, would light travel faster than the speed of light as we know it now, taking everything out of the universe, forces, particles? And I proclaim that we can actually kind of prove it, because the visible universe that we see now consists of matter, and beyond our visible universe, there is I call it the dark verse, the dark verse. So what's out there in the dark verse? Obviously, it may not, well, not obviously, but there may not be any matter out there. It could just consist of a weak force, or weak energy, weak, not like we have here. So if light were to travel through that dark verse, will it travel faster than the speed of light as we know it now? So can we prove that? So that's a question to think about. Like from the inception of past videos, I've said that you can win the Nobel Prize in physics by answering these questions, right? We have presently now one of the main questions is, why did the universe expand so rapidly? And one of the theories now that they claim that it's because of cosmology inflation theory, and that's being taught in universities, colleges, and that's accepted. That is supposed to be the most logical theory to explain the rapid expansion of the universe. You have to understand there's an operative word, logical. Logical does not mean that it's true, but it is accepted. So why can't you come up with an accepted logical theory of UFOs, propulsion, alien propulsion, and situations like that? You can be intuitive, right, from seeing the evidence out there. Well, wars like evidence or patterns out there, and you can be intuitive. I spoke about Madame Chatelet, and when she proposed that light was massless, a beam of light is massless. This is like 300 years ago. So these are the things that you can propose. You can come up with an idea, a theory, and it can be revolutionary, and yeah, analyze it. This is why I said I'm going to call myself a rat. Revolutionary analytic theorist. Then we have string theory, which is being taught in colleges and universities, but that has not been proven either. You know, we have the Large Hadron Collider, which has not produced the particles as string theory predicted. So these are the issues. And, you know, string theory is being taught in colleges and universities. In fact, one physicist won the Nobel Prize for, you know, for the theory. So, and the reason from what I gathered that she won the Nobel Prize is not that it's proven through the LHC, the Large Hadron Collider. It's just that it was very popular, and you know, it was a popular theory, and she won it. So why not you? So it's not proven yet. You have not seen any supersymmetry. You know, one for one particle, you have a supersymmetric particle. So if you have an electron, you're going to have a partner particle, which they call it the selectron, etc., etc. So I can't have you watching an empty sky. So this is why I'm going to have the discussion with you. And in fact, I'm going to take you to my whiteboard. I believe I'm going to discuss with you. Let's see. Inflation, cosmology, inflation theory. So I'll discuss that with you. Very fundamental, elementary. But if you can come up with a more logical explanation, then you can win the Nobel Prize in physics, you know, also. Because it's just a logical explanation that's being taught in colleges and universities. So join me at my whiteboard, and it's just going to be a brief discussion. And in the future, you know, on some of my videos, I'm going to go in depth. So I'll see you over the whiteboard. It's going to be just a fundamental brief on, you know, cosmology, because cosmic inflation theory. See you then. Well, since we have not seen too much any activity for UFOs over the city of New York, I take some things earlier. So I figured, hey, let's talk about it. In the past videos, I had spoken about Madame Chatelet. One of the videos, Madame Chatelet. I also spoke about you can win the Nobel Prize in Physics. I also spoke about if you were to get rid of the rubbish in the universe, for example, the planets, the stars, black holes, dark matter, dark energy, electrons, fundamental forces, fundamental particles, and so on, with the speed of light as we know it, travel faster than light. Now, we have a dark verse. We have the visible universe that we can see. But beyond the visible universe, I don't know if anyone ever came up with this term, but I call it the dark verse. The dark verse, like I had spoken earlier, would have different properties. Would have less energy, less forces, minute forces, and so on. So we can prove if the speed of light as we know it, going through the dark verse, which have different properties, low energies, practically no particles, but they go faster than the speed of light. Would space be the same as we know it today? So that was the question I had asked earlier in one of my videos. I also spoke about Rat, the revolutionary analytic theorist, if you have a theory and it's revolutionary, analyze it, who knows? It can, it could be that you can win the Nobel Prize in Physics. So, that's said and done. Now, we have string theory within, I don't know, 6 or 7 years that they develop it. And actually it's been taught in colleges and universities. And that's not proven, right? Because originally, I believe it was 20-something dimensions that you would have to mathematically put it together with Einstein's gravity, to put it together with quantum gravity to become a theory of everything. So string theory has not been proven for the simple fact that for every particle that we know, you have to have a partner particle. So if you have an electron, you're going to have this electron. So the particles have to be partners for us to come up with a theory of everything, for them to come up with a theory of everything. Then we have M theory, which I'm not going to get into. And the particles, the part of shape, they call it supersymmetry. And most importantly, the LHC, the Large Hadron Collider, has not come up with the supersymmetric particles, which is a part of particles, so the particles that we know of right now. And billions of dollars has been spent, so that went, that got thrown into the garbage so far. Now, let's go down. The reason why I'm saying this is we have been out there and we have seen UFOs, almost all of us. We cannot explain it, right? But yet they're telling us, Carl Sagan has said, extraordinary claims need extraordinary proof. So that's what they have been saying to the people who believe in UFOs and who have seen UFOs. But yet, they are claiming extraordinarily claiming that string theory is the right theory without any proof, and it's been taught in colleges and universities. So, let's go one more. I'm just going to give you a broad overview of, and apparently someone won the Nobel Prize in physics for string theory, right? Because that person was very, popular, so they gave that person the Nobel Prize in physics for popularity. So let's go down to cosmology, inflation theory. Came up, I don't know, I guess when I was about, say, let's say 50 years ago. So they came up with this theory, right? Because they wanted to explain why the universe expanded so much faster at the beginning of the universe. So they came up with, one physicist came up with this theory, cosmology, inflation theory. So he claims, and this is being taught in colleges and universities also, with no, I'm going to get back to that because I'm going to write the word, logical. That's the word we have to remember, logical. And then I'm going to just put explanation. Whatever. So remember this word, logical. So the universe expanded, I don't know how many times fast, and it's still like, it's an enormous amount of, exponential expansion. But expansion can be worked out for simple math. We all know velocity equal distance over time. So if we say, 300 years, 300,000 years from the beginning of the universe. After 300,000 years, light did not, come into view because you need a magnetic. You need interaction with particles to form light, and they claimed there was a soup. But anyway, it expanded. And you can calculate this with simple math, velocity equal distance over time. Fine. So now it expanded, and it expanded exponentially. And that expansion need to explain, because everywhere you look into the universe looks the same, right? So why would it look the same? Because the beginning of the universe had to be in casual contact. You have to be in casual contact, right? You have to be in contact, so that if someone if you here, this is the expansion. A person here, just think of it as a sphere. A person here, which is 13.8 billion years ago, the universe expanded. You here will see the same thing here, and you are here, you see the same thing over here. So that means that a person here from here that's looking at each other sees the same thing that's out here and out here, right? But this is only 30 million years. So how is this guy going to be in contact with this guy because this is the same all the way around? So there's a casual contact. So whatever happened at the beginning of the universe, it has to have some kind of casual contact, right? That's called causality. Now, they're talking about, and this is where the inflation theory comes into being. And what the inflation theory is saying, that the Big Bang expanded very rapidly. We're talking about 10 to the minus 30 something seconds to expand. I don't know the numbers. The numbers, it's not difficult to find out, because velocity equal distance over time. So it's simple to calculate it. So now to explain this rapid expansion, the cosmology inflation theory was proposed. And it is being taught, like I said, in colleges and universities. But why? Right? There's no proof for it. But the only thing that is saying is that is the most logical explanation. So now when we talk about UFOs, and then we can teach UFOs in colleges and universities, and they should not object, because it is the most logical explanation for what we see in the skies. Right? Because there's no proof for cosmology inflation theory. Right? Now we're talking about homogeneity. Before we get into that, what I did. Homogeneity means that the universe pretty much is uniform. So that's what that means. And causality means that whatever started the universe had to be in contact with each other, and it's expanded. So whatever expanded, whatever is here is going to be here because it was in contact with each other. So over here would be, the properties of there would be over on the other side. Now the person goes on to say, well, the rapid expansion was caused by a repulsive force. Well, we know we have attractive forces, right? So it expanded so rapidly, but it had to slow down as we see the universe today. So why did it slow down? Because at the beginning, there was a repulsive force. Well, wait a minute. It expanded so rapidly. I mean, the numbers is extraordinary. So let's find out about the repulsive force. So it expanded for whatever time, a minuscule time, and then a repulsive force now started to act. And the repulsive force acting on the universe, as we can see the expansion of the universe now is way, way more slower than the rapid expansion. So now there's a repulsive force, a repulsive, actually, gravity. What is it? Repulsive gravity force that slowed the universe down as we see it today. So now the idea behind the repulsive gravity force is, as I may say, right? It has to be I don't know, a cosmic super brakes, right? Cosmic super brakes to stop this rapid expansion because of the repulsive gravity, right? To stop it, the repulsive gravity. So we have to have a super brake. So you have to believe in the cosmic super brakes. Okay, that's fine. Then we continue on. Then we realize that the universe now has been speeding up. Well, the repulsive force stopped the universe from expanding. Stopped the expansion of the universe for about 7 billion years, right? Let's call it 8 billion years, right? Because it slowed down to what we had known back in the past. Then 5 billion years ago, we found out now that the universe started to expand. So what happened now to the repulsive force, right? So now, when the universe slowed down, they said that the repulsive force decayed, right? And it slowed down in the radiation. I mean, it stopped. The radiation of the whatever repulsive force stopped. So now, when the universe started to speed up, all of a sudden the repulsive force now comes into play, right? So now it's speeding up, right? 5 billion years ago, the universe is speeding up. So what I'm trying to explain to you is this. You believe in UFOs, like I do. We cannot be the only people on the face of, in the face of the universe. But I don't want to get too much into a lot of issues. What you see is what you see. And we have all seen these things. And we are trying to explain it. And the idea behind what I'm trying to explain to you right now is that they believe in string theory. They believe in M theory, which I'm not even getting into. Right? And cosmology inflation theory, so, which has not been proven. So so whatever theories you come up with, it's your theory. And they cannot disprove your theory. Because you've seen what you've seen. And we have a pattern, and if we have a pattern, this is how physics, the laws are made. If we have a pattern, we observe things, and there is a pattern, then we need some proof. Right? Now, they're saying we need extraordinary proof to prove an extraordinary, what is it? Did I get into the theory of everything? Well, the theory of everything, actually, they try to put Einstein's, I believe I said that, Einstein's gravity, which is the gravity that we know, the explanation with quantum gravity, to form the theory of everything, a mathematical concept. All right, so there's that on that level. Now, I'm going to talk about my theory. So my theory is, I'm not going to get too much into it because it's for the future. But I'm going to give you a little, what do you call it? A little, I don't know. You figure out the word. But my theory is this. But not my theory. I'm going to give you some words. Right? And my words are this. These words that I use. I use words like, we know we cannot have infinity, right? There's no infinity because we will not be here. So I use terms like AIP. Before the universe that we know it now. I call it the almost infinite period. Even period denotes time, but that's what you gotta use some kind of word. And then I use the word AIN, almost infinite number, right? So these are the words that I use. It cannot be infinite. So then I use words like the cosmic cake. Cosmic cake. And I'm going to give you a brief explanation about the cosmic cake, right? If someone asks you to bake a cake, and they don't tell you what kind of cake, or you don't even know the ingredients, how can you bake a cake? Or even if they gave you certain ingredients before the universe has started, they give you the ingredients. So what are the ingredients? Some energy, some expansion, contraction of the universe before we know it. So it goes through numerous expansion and contraction, but we came out of this cosmic cake. So it will take an almost infinite period before we came out of the cosmic cake, right? So you can put your flour, your baking powder, baking soda, salt, sugar, whatever, and when you make that cake and you take it to the person, then that's not a cake I want. Because you have no idea, so you have to go back and mix it over and over and over until the person said that's the perfect cake. But this is the perfect cake we're living in this universe, because we are the company of the cosmic, because the universe came up with the perfect cake to make this universe. This is why it needs to be called a cosmic cake. Now, there's a cosmic shock wave, right? That's my theory. Because if we were to look at homogeneity, there must be something that's smoothing out the universe, because the universe is smooth right now. There has to be a force after just after the Big Bang to smooth out the universe. This is why I called it the cosmic shock wave. But we're getting more and more into that in the future. Right? Now, I also propose that I can tell you exactly where the fundamental particles, the fundamental forces, exactly where at the beginning of the universe, where these forces and particles were created. Exactly. But you never hear any physicist says, well, there may be an exact point at the beginning of the Big Bang where these forces were conceived, right? You never hear anything like that. But you are going to hear the first time I can pinpoint exactly where in the Big Bang these forces and fundamental particles or elementary particles were created. Exactly. If I tell you it was created here, I'm saying in a zone. In a zone, right? In a zone. I'm not going to say just right here. I'm just going to say in a zone. You have here and you have a zone around here. This is where say for example, the electroweak force would be created. The electromagnetic force, the electroweak force will be created. Exactly where in that zone it will be created. And another thing, they're saying that particles are generational. So you have different particles. I can tell you exactly in the zone, because there has to be a certain zone where these particles were created through the energy levels of the Big Bang. And this is the first time you're going to hear about it anywhere, because I can show exactly where these particles were created. So hopefully I'm going to end it right there. And in the future, when I scan the universe and there's nothing else to show, I'm going to come back and then we're going to exactly where these zones and fundamental particles and these forces were created. Right? So hope to see you guys soon. Sorry about not seeing any UFOs now, but I will keep my eye out over the skies of New York. Thank you.